Now we're going to look at epoxide opening using a nucleophile. So instead of starting with an acid to protonate the epoxide, what we're going to do is use a strong nucleophile, one that's strong enough to break it open on its own. So here's some common strong nucleophiles. You see that they're all negatively charged, things like O-, Cn-, sulfur-, N-, or carbon-. These are all strong nucleophiles. There's a big difference here, though, in the regiochemistry. So under acidic conditions, our nucleophilic source attacked the more substituted carbon because it had the most positive character. Well, in this case, the nucleophile will attack the less substituted carbon. So this is purely a steric effect. Now, we call this non-acidic conditions because the epoxide's getting opened under non-acidic conditions, but you will see that these reactions always require an acidic workup to protonate the oxygen. So let's draw the product for this reaction. We're treating it with NaSCH3. When you see a reagent like this, go ahead and break that apart. Na plus is just a spectator ion. SCH3 minus is the nucleophile. So what's going to happen here, if you look at the two carbons of the epoxide, the one on the right is less substituted. With the nucleophile coming in, it's going to go for the less substituted carbon here. So that SCH3 will attack that carbon and break open the epoxide. When it does, you end up with O-. And then added here, the nucleophile SCH3. So here's why we need that acidic workup step, because you have O- that needs protonated. So in a second step, after all of this is reacted with your epoxide and everything gets converted to this species, now we can add acid to work this reaction up. Again, this isn't added until a second step. Here we protonate the oxygen. And there's our product.